All right, by the end of today, our goal is to be able to use technology to find the equation of line of best fit. We were working on that yesterday. Interpolate and extrapolate from the line of best fit, and be able to tell if a set of data should be represented with a linear line of best fit or an exponential line of best fit. Okay, that's our goals. So here, Unit 9 has its two variable statistics, line of best fit with linear and exponential. So first off, we're going to use this to find the line of best fit. So let X be the year since 1998. So that would mean this is year 0. This is year 1. This is year 2, year 3, 4, 5, 6, 7, 8. So I'm going to go to Stat, Edit. I'm going to clear my data. Then I'm going to do 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then I'm going to come do this one. And we're going to plug in 1289, 1311, 1340, 1339, 1406. And remember, this is tickets sold in millions. So this is 1,289 million tickets. It's a lot. So then 6 is 1470. Or no. Did I get off? Yep, I did. Go to. Okay, clear. Let's see. 1289, 11, 1311, 1340, 1339, 1406. Oh, that's because I didn't type a 4 over here. 4, 5, 6, 7, 8, no 9. Okay, so we've got 1406, 1421, 1470, 1415, and 1472. All right, so then we press Stat. We're going to go to Calc, Linreg, L1, L2. We want to put the equation in the Y1. Okay, so the function that represents the line of best fit is going to be Y equals A being 23.1, X, and B being 1292.38. Okay, the correlation coefficient is R equals, and remember, if you don't have R, that means you didn't turn diagnostics on. So go and look at the calculator steps for that. So R is 0.94, which is a high positive correlation. Okay, and then it says predict what year the movie sales will reach 15. So what year will the sales reach 15 in millions using the regression line? So this means my Y would be $1,500 million. And then I'm going to be solving for X here. Now, I don't know about you, but I don't really want to do that. So I'm going to come over here, and I'm going to change my Y too. So it's 1,500. From here, I'm going to press Graph. Oh, my graph is not going to show me what I want. I'm going to press Y equals. I'm going to press window. My X values, I'm only going to go from 0 to like 20. We're going to go by 2s. And then my Y min, we're going to go with, let's see, my lowest number here is like 1289. So we'll go with 1200. And we're wanting to know 1500. So I'm going to change this to 1550. We're going to have this go by hundreds, just so it's not overwhelming. So now I'm going to hit graph. There's my pretty graph. that's where they cross. So this is the year, whatever the x value is there, where they cross is the year that we hit 1500. So I'm going to press, so we're going to hit second, trace. We're going to go to intersect because that's what we want to know, where they intersect. Now we're just going to press enter 3 times. Actually 4 times. So it says the intersection is at 8.987975. So that's going to be, I'm going to round up. That's going to be at 9 years after 1998. So that would be 2007. So x ends up equaling 8.98 or 9 because we're rounding up, which is going to be 2007 for this particular theater. So it says, what would you expect the movie sales to be in 2015? First thing we need to know about 2015. How many years after 1998 is 2015? So we're going to take 2015 minus 1998. We get 17. So this is 17 years later. Okay? So I'm going to go to my y equals. I'm going to go to my graph. And I'm going to hit trace. And I want to do 17. And I hit enter. And that's 1,685 million tickets. Sold, if you want to write sold. Okay, so that was really good practice for us. That was fun. So much stuff on the calculator. All right, so here, this is going to be the number of years since 2000. So this is just really 1, 2, 3, 4, 5, 6, and 7. That makes my life easy. And then these are hourly earnings in dollars. So I'm going to go to my graph. Actually, I'm going to go to my stat, calc, actually stat, edit, edit. Let's edit our list. Clear. So this first one is going to be 1, 2, 3, 4, 5, 6, 7. And then her earnings is going to be 10, 10, 50, 11, 13, 15, then 1575, then 1650. All right. So we're going to write the equation of linear regression. And we're going to say, what does the slope tell us about the story? What does the y-intercept tell us about the story? And then using your regression equation, predict her hourly earnings in 2015. We're going to also identify the correlation coefficient and interpret the strength and direction, if it's positive or negative. So we're going to press stat, calc. We want a linear regression. L1's great, L2's great. We want to store the equation in our y1. And here's our equation. So it's going to be y equals, my a value is 1.21x plus my b value is 8.25. So the slope is 1.21. So this slope is talking about dollars per year. So it would be her raise per year. So she'd have a raise of about $120.21 per year. So the y-intercept is $8.25. This would be her salary, or her hourly wage, in 2000. Okay, so let's go ahead and change our window. I want this to go only from 0 to 10, actually 15, because we want to predict it 15, so let's go with 17. We're going to just go by ones. My y smallest number is 10, so it's going to be okay if I start at 0. My y maximum number is 1650, and I want to know what 2015. So I'm going to go ahead and do 25, and we're going to just go ahead and go with 5s here. So I'm going to hit graph. So that's what the graph looks like now. And I want to know her hourly earnings in 2015. So this is plugging in 15 because it's 15 years after 2000. So I'm going to press trace, then 15, and I get $26.46. So her hourly wage would be $26.46. Okay, and it's already gotten rid of my correlation coefficient. Let's go ahead and bring that back. So my correlation coefficient is 0.98 and then 0.006. So it's 0.98. This is a strong positive correlation coefficient. Okay? All right. Now I want you guys to go ahead and do this. Answer all the questions that you can. And then once you're done with that, we will come back together on this one. All right?